Howdy Pre-Cal students. I'm talking to you from Monday evening and I'm about to go over the notes for 14.2, using identities to solve trig equations. So in 14.1 we were solving trig equations by factoring, in which case we had like quadratics where we could factor it like a quadratic, or else you had common factors, you could factor it that way. But sometimes you have a situation where neither of those things applies. For example, look at number 1 here. 3 cosine x plus 3 is equal to 2 sine squared x. This is not going to be a quadratic. If I get everything equal to 0, I'm going to have cosine and sine squared and a cosine, and I can't factor that. But anytime I have this situation where I have cosine with a sine squared or a sine with a cosine squared, I can use the Pythagorean identities to replace my squared term. Remember, the Pythagorean identities always apply to the squared terms. So I'm simply going to replace sine squared here. I'm going to leave 3 cosine x plus 3 as is. And I'm going to replace sine squared with 1 minus cosine squared, because that's what it's equal to in the Pythagorean identity. Sine squared equals 1 minus cosine squared. So let's distribute the 2 here. 3 cosine x plus 3 equals 2 minus 2 cosine squared x, and now let's get it equal to 0. And since I have a negative 2 cosine squared, I'm going to move everything over to the right. That's going to become a positive 2 cosine squared. I still have this positive 3 cosine x, and I'm going to subtract 2 from both sides, and when I do that, I'm going to end up with a plus 1 here. Plus 1 equals 0. So now I have a quadratic, everything's cosine. We're good to go. If you want to replace, again, if you want to replace cosine with some other letter, cosine x with k or a or b or whatever you want to do, that's fine. That'll work fine. Again, this one should be pretty easy to factor. I know the only thing to give me 2 cosine squared is going to be 2 cosine times cosine. The only thing to give me 1 is going to be 1 times 1, and everything's positive. So it should work this way. Let's just check the outside's a positive 2 cosine. Inside's a positive 1 cosine. When I add those, I get 3 cosine, so that all works. Using the zero product property, we'll split that apart. And now we'll just solve each of those. So 2 cosine x equals negative 1, and cosine x equals negative 1/2. Over here, cosine x equals negative 1. So let's start with that, because that's going to be the easiest one. On the unit circle, my x value is equal to negative 1 at pi. So cosine x equals negative 1 at pi. Over here, cosine x equals negative 1/2. That's going to happen, alright, so x is equal to 1/2 at pi thirds. But I want negative values. I know that cosine is negative in the second and in the third quadrants. So this is going to be 2 pi thirds and 4 pi thirds. Okay, second and fourth quadrants there. Excuse me, second and third quadrants. So there you go. I've got 3 answers: 2 pi thirds, 4 pi thirds, and pi. All right. Let's look at number 2. Cotangent x is equal to the square root of 2 cosine x. Again, there's no quadratic. I don't have a squared term, and I don't even have any common factor here as is. But I can use the identity. I know that cotangent is equal to, cotangent is equal to cosine over sine. So I'm going to rewrite cotangent x as cosine x over sine x equals root 2 cosine x. And now I want to get rid of the sine x in the denominator, so let's multiply both sides by sine x. My sine x's will cancel. I've got cosine x equals root 2, and I'm just going to turn that around because we just for some reason we usually put sine in front of cosine. Alright, I'm going to subtract the cosine x from the right to get this equal to 0. Alright, now I do have a common factor. Now since I've switched the cotangent to cosine over sine, I have a common factor of cosine. I can factor that out. So cosine x times square root of 2 sine x minus 1. Zero product property, let's split it apart. Cosine x equals 0. Square root of 2 sine x minus 1 equals 0. So square root of 2 sine x equals 1. Sine x equals 1 over square root of 2. And when I rationalize that, I'm going to get root 2 over 2. And I'm just going to bring this, just to put them next to each other here, cosine x equals 0. So where does cosine equal 0? Well, cosine equals 0 at pi halves and 3 pi halves. Sine equals root 2 over 2 at pi fourths. And sine is also going to be positive in the second quadrant, so that would be 3 pi fourths. So pi fourths and 3 pi fourths. Now since I didn't start with just sines and cosines, I do need to check these answers. My term up here I need to worry about is cotangent. And cotangent is going to be equal to x over y. So I'm looking for where y is equal to 0. Well, y equals 0 at 0, pi, and 2 pi. That's where cotangent will be undefined. 0, pi, and 2 pi. That is not any of my answers, so these answers should work fine. These should be good to go. I don't have to worry about it not working in the original equation because it's undefined. So pi halves, 3 pi halves, pi fourths, and 3 pi fourths. All right, last one, number 3. Sine x minus cosine x equals 0. So this one, let's just get this. I can't factor it, so I'm just going to add cosine x to the other side. I'm going to say sine x equals cosine x. Remember that sine is my y value, cosine is my x value. So basically we're just saying, all right, where does y equal x? So again, think about your unit circle. Where are y and x equal to each other? Well, they're equal to each other at pi fourths, right? They're both square root 2 over 2 at pi fourths. And then they're equal again in the third quadrant where they're both negative square root of 2 over 2. And so the answer would be pi fourths and 3 pi fourths. That's it. That one's actually fairly easy if you just kind of think about it. Okay? That is it. Good luck with the homework. Send me questions through Schoology if you want. I will get back to you as soon as I can. All right? Hope y'all are doing well. I miss you. Bye-bye.